Hey, hello, welcome to this Global Hack Week Games Week. So, my name is Alberto. For those one who don't know me yet, I'm from Mexico, and I see some familiar names here. I see Caracas. I remember we were playing Tetris a couple hours ago, but also the good and old Green Yashix. It's so nice to have you here, and Spicy Gluten One. And welcome to everyone who is joining us. Shelby, I think it's pronounced. I don't know. I want to start by reading some comments. I know you're having a conversation here. Hello. How it's going on, Chad? What time is it for you all? So that's a really good question. I see some 11 p.m.s, I 8 p.m.s, and it is 9 p.m. for me. So actually, I got planned. I got scheduled these uh, workshop for 10 p.m. my time zone. But then Mary remembered me that ET time just changed due to time savings, something like that. We used to have that here in Mexico, but the current president removed that. It's only one time zone for us now. No time changing at all. So I got to reschedule, and that was funny because it, I think it interferes with some things I had planned, but well, nothing we cannot sort. I see here, in Asia, so it's 11 a.m. over here. Well, that's 12 hours difference, so a huge gap. But thanks a lot for being here. That's amazing. I really love to have the opportunity to reach the entire globe, like um, go to the other side completely. Like you have the sun that I don't have in my head right now, but also even I don't have the sun. It's kind of warm here. That's really weird. So the weather lately has been horrible. I don't enjoy the warm weather, and lately it's just warm all day. So let me see. Plus channel points for watch streak. Oh, that's amazing. You're on the streak now. That's really cool. Hard at work on the Lettuce game right now. You have to explain to me what about the Lettuce. I know I have to ask Dimmer, but I am really feeling that this is something I got to know right now. Okay, exhausted, very cool. Oh, nice. I do some ideas. It's the vertical scroll you were saying, or I would love to see them if you share. Okay, I am guessing you're talking about a project or something. Um, Tower of Lettuce. How is it going? Yeah. Aniket, I didn't mention that name, but here we are. So cool. When making JavaScript games, can it work with different browser sizes? For example, like Flexbook, so you can play it on phones as well? Yeah, of course. Actually, I won't say that the matter here is about the screen size because there are media queries, so you can resize your game for whatever screen size you can work. For example, you can think not only smaller but bigger. I right now in a I think it's 32-inch monitor, so I have a plenty space to play video games here, but also this works for the same developing with the same code to my smartphone. So that's amazing, and that's the real powerful of JavaScript, right? So great question. Hey Alberto, here from Black with Hackathon. That's amazing. I spent a really nice time on Black Wings hackathon. And how did you do? Like, you win? You were one of the winners. I hope you are. Um, hey, y'all. At the one from the stream earlier today with the design 101. Yeah, all right. I'll take a look and I've sent you over. Ready to learn game dev in your yes. That's the attitude. Really cool. The latest is a long story. Yeah, don't worry. I can live without it. I am completely new to JavaScript. Will it work? Yeah, of course. Um, I yeah, don't worry. You will learn a lot during this session. It was a whole conversation with Dimmer and Ryan and a few others yesterday during the type race event. But Dimmer gave me a challenge to make a game that you can only control using a piece of ledger. Oh, so you are going to implement hardware as well, like connect some wires and stuff. That will be very cool. Yeah, I don't know if you're talking about the lettuce challenge or the JavaScript session we're having here, but both I think they are very exciting. So that's all the comments I have here. Thanks. This is a big audience, so that's amazing. I see a lot of people commenting and stuff, so I'm very excited. And remember, this is the first of a series of three workshops we are having. So in this first one, and we are entering to the topic, uh, we are going to talk about what you need to do web developing. No, sorry, games in web. So yeah, it's kind of web developing. So let's call it video games in web developing, right? So what you need to do it, and we are going to use two resources. In this case, we are going to go full vanilla. This is going to be kind of complicated for those ones who don't know anything about web or JavaScript, because we are going to talk about low code. And even though JavaScript it's not low code, well, it's not considered as low code, but we are going to program as we were on low code. What does low code mean? When you say something it's slow, you're referring that you will have to take more action in the things that you will program, let's say in that way. Let me rephrase it to be more clear. Imagine you're programming in C or in Java, just Java, not JavaScript. Those programs are more considered like low code for the reason that you have to be more specific in the things. Like, for example, in JavaScript, you can say, hey, I want 2 plus 2, and I want to display it in a screen, in the console. And JavaScript just take a lot of information from you, like, and say it like, I'm going to make this possible, right? um, I don't care if 2 plus 2 gives 4. I'm going to translate it in a string and then console log it to your screen, or even put it in a HTML tag, for example. And even you can do 2 plus 8, and that it's possible in JavaScript, right? Because JavaScript is amazing. But in the other languages, again, in C, for example, or Java, you have to be more specific. You have to say, hey, this variable it's this type. So if this variable is this type, I need to make an operation that yields uh, something about that type, right? For example, if you say float, you have to operate with two floating numbers. You cannot use an a like in JavaScript. And even if you want to display it somewhere you have to be very specific, like I don't know, in which part of the window, what color, what font, and those kind of things. So when you get lower in the languages, uh, you have to set more rules. You have to be more specific with the things you're talking about. Um, the language doesn't give that interpretation, let's say, for what you're saying, and you may thinking like, well, so why low code? It's good because you have a lot of control of performance, of yeah, that's the thing. So you have a lot of control of performance, and you have a lot of control of what actually it's happening in the computer. So normal low code languages for the computer environment are even what's the name for this, assembly. So assembly is like the most low code of all. Like you're practically typing in bytecode. That's the lowest you can get at bytecode, you know. So that's what I mean with low code, and why I am saying that in this case we are going low with JavaScript. Well, the thing is that we are going to use a standard called WebGL that it's based on OpenGL. That it's what's the name for this? Sorry, I forgot the name. Graphic, yeah, a graphic API or a standard. Um, so in this case, yeah, for example, if you have tried web developing with JavaScript, and you have tried, I don't know, to draw, you can do it with CSS and HTML. That's really cool. And I don't know if you can do it. I don't know if you knew you can do it with pure JavaScript, and just painting on an HTML canvas, and that's a great thing. Um, but here again, you're using like small fractions of code that someone else already programmed, and you just like implementing it. But in this case, with the capability of WebGL, you can do a lot of things. Like the entire your imagination is the limit. You can go really specific on the shapes, on the colors, on the animation, on everything. I mean, like it's really cool. But why you want this? Why you want to spend a lot of time, like me, drawing a colorized rectangle with more than 300 lines of code, when you can just simply uh, just say like, hey, deep, um, with 200, hey, 200, background color this, and that will have a very similar result. Well, because you want performance. Because no, I'm not sharing any slides. I am just talking because I see here the comment. If you if you're wondering why I'm looking like at this point, is because again I am using a big screen, so I'm monitoring like the stream here. Yeah, uh, cool. So again, sorry, I missed the track. You want performance because you're building video games. Uh, in some cases, you have to care about these things, and this is when the things got complicated. At first, I thought how to structure this series of sessions to teach how to build video games. First thing I thought, it's starting using like the frameworks and just go and quickly develop a video game. But then I realized that does not go with my way of thinking. I really believe that you need to understand at least what's happening. You need to understand like the basics of all things to start building things fast. And that's why we're going to take this session to understand what's happening in the browser, why you are implementing this, and then we are going to program not a one but two quick video games in 2D, and they are going to be really cool. But you will see the effort and you will see all the things that it's happening behind to get this quick or easy or not as complicated video games running. And then tomorrow we are going to use a framework to do this, but times quicker. And that time will give us the advantage to implement and to do more complicated video games in 2D again. And in the third session, oh wow, what was that? Oh yeah, I remember if I do this, like, okay, I got distracted again. Am I the only one who saw the balloons? Am I getting crazy, or are you? Do you see the balloons? Well, I don't know what I did to get the balloons, but in in the last session, we are going to implement a 3D video game using another framework and assets that are pre-built. Because remember, one of the biggest challenges about creating video games, it's not only about the logic. Logic, it's hard, yes, but having the assets, having the materials, having the textures, having all the graphic things for a given video game, it's like the I will say it's like the very big part of video game developing. I'll tell the balloons, but you still might be crazy. Yeah, I might. I don't know. You saw them. That's really cool. I don't know what I did to balloons. Okay, I completely don't know. Um, yeah, this was funny. Um, yeah, and as I was saying, the logic is hard. Yes, yes, but I want to give a big shout out to the people working on the models, like the people that does Blender, that does materials for the graphics, for the sounds. So remember, if you want to work, well, see you on the video once it's on the Emulate channel. Okay. Um, yeah. Remember, if you want to start a video game company, or want to do this full time, you will have to you will have to give credit and start caring about these things. Remember the last time you were playing a video game? I think one of the most impactful things is it's the graphic environment, the landscape you're drawing, like the character you're playing, the weapons, I don't know, the assets, this props even. That's a big thing. But what we care about right here, because we are hackers, it's like the logic, right? So we're going to use some library assets, and we are going to build a video game. But that's for the third session. This was just a spoiler for that. Oh, very good. It was like 22-ish. um, so let me start sharing my screen. Um, and I'll fully share this. Okay, now you should see this. And where are we? Well, with the best friend of the web developers that I introduced to you. If you haven't met this, Mozilla Web Development Documentation developers .mozilla.org. So I will share this to you on the chat. Well, yeah, the comment section. So if you want to head to this, what you can find here, well, this is very cool. You can find reference for HTML, CSS, JavaScript, protocol of HTTP, the web APIs. If you have been in our classes of mine, you know I really love this page, this documentation. The web extensions, web technologies, you can find guides to learn HTML, CSS, JavaScript, accessibility. That's really, really important. Um, Learn about all web development areas. You can find things about curriculum. They are releasing a new beta in AI help, and a lot of things. A lot of blog posts with really cool information. And what we are going to check right now is this one, the web APIs, because you can think of this that I mentioned before, this WebGL thing, as a web API, as it lives on the browser, right? So you can access it right here if you go to web API. So I have opened it here, and as you can check, we have the beacon, the CSS APIs, the DOM, document object model. Remember, that's very important for web. The fetch API, the geolocation API, for example, the Houdini API, for example, indexed, DB, streams, navigation, permissions, the SVG, selection API, topics, lots of APIs, right? But what we're looking for right now is this one, the WebGL. And this with W, it's a very big section. You can see the NFCs, the crypto, the authentication, the audio animation, share, speech, storage. Well, lots of it, right? So let's take a focus right now here on the WebGL. I don't know why, if you open this, you are left to. Oh, okay, no. This is the correct link. At some point, I clicked this and uh, it was Wikipedia, the link that was opened. So maybe, yeah, maybe that's an issue for the Spanish version. So yeah, it doesn't matter. Uh, so come here, click it, click on the WebGL, and you will see an explanation about what WebGL is. Again, WebGL, it's the web graphics library. It's a standard based on the OpenGL thing here. For example, WebGL2, it's true support for merge OpenGL3 features, blah, blah, blah. Before continuing here, I want you to look something that, for example, if you Google WebGL, the first thing that appears, it's this WebGL with the URL get.webgl.org, and if you hit it, you will only see um, a page that tells you like the if in the current browser you're using, uh, if your browser supports WebGL. So this is not as handy, I have to say. Well, it is handy if you just want to know if your browser supports it, I guess. Uh, but that's not what we're looking for, right? Um, OpenGL and WebGL are from the same company that is Kronos. So if you have to scroll down a little bit, and you will find the Mozilla, of course, the Wikipedia one, this one, I don't know what it is. Unity manual, because if you want to develop games using the Unity game engine, you can do it. That's really cool. But here, this one, the Kronos group, and you can find here the explanation about WebGL, and it's this page. Well, Kronos Group software connecting software to silicon tells you that WebGL is a low-level 3D and 2D graphics API based on OpenGL. Yes, this is a closed platform, royalty-free web standard for low-level 3D graphics based on OpenGL, exposed to ECMAScript via the HTML5 canvas. This is very important because we need a canvas that indeed it's an HTML5 element to get used of this. So developers familiar with OpenGL recognize WebGL as a share-based API using web. What's the name for this? It's WebGL shaders language, GL shaders language, something like that. But we're going to use this in a couple of minutes. Yes, give it time. With constructs that are semantically similar to those of the underlying OpenGL ES API. If you want to learn more about this, that this is really low, so it's a good way or a good practice to try to understand the most you can for you if you want to go and to go serious with game development and in web. So I'm going to share this. Do you want us on the Kronos website or still we in the Mozilla one? We are going back to the Mozilla one. I just wanted to share to you this page of the Kronos website so you can take a look at your own time. Yeah, let's get back to the Mozilla one. Here, for example, you can see lots of tutorials, extensions, guides, and even the public reference of the interfaces and events happening on WebGL um, API. And the one I really recommend you, it's the tutorial called well, it was not a tutorial. It's on the guide section. It's called WebGL by example. Um, it gives you examples of how to use all these interfaces, but in a more friendly way. Because if USB learn by doing, well, this is the way, right? So you probably notice I have this tab open called Game Development. This is a dedicated section on the MDN web docs, but we are going to get here on a second. First, we are going to use this WebGL we were talking about a lot of time to build our first two video games in the web, right? So, this is the exciting part. Let me share with you this example I got prepared. And we are going to code this first example. We are going just to analyze it, and then we are going to create a blank project to start coding our video game. So you probably see it right now. This is a really simple HTML. We have just our opening and closing tags, our head, our body, and if you see what's happening here, actually, I think I can delete this, but okay. This is a just WebGL demo of how to render two-dimensional rectangles. The thing we are using here, and we mention it, very important, it's the canvas. So the body is very simple. Even I can only get the canvas, but for styling reasons, I put it between two divs. I style it with display flex, justify it to the center, and I add a color to the background, just a clear color for being nice. And we have two scripts. The first one is this call to the rectangles. Yes, this other one is the CDN of a library called GL Matrix Minified. But for what I remember, I can get rid of this because it is not working properly, and I had to do it this other way, which is importing from the CDN Skype back then. Um, but yeah, starting with this, we have a main function. This main function gets the canvas element from the HTML just by the ID. So we have the document that query selector ID GL canvas. We have it right now, and from this canvas, we initialize the GL context, WebGL context, by implementing that method. As simple as that. Dot get context and between quotes WebGL. So we have now our instance of WebGL. So only we have to be specific. If you remember the page with the uh, animation of the rectangle, well, it is important to know that your browser supports WebGL. Not all browsers does it. So if the instance of WebGL is not valid, we just have to notify, hey, you cannot use WebGL for your browser. Try with another one, right? And then we set a color to this canvas we're using, and we specify that, if you see here, as black, fully opaque, right? And we clear it with the GL color buffer. And at this point, we just have a full canvas, very black. So let me comment the other things inside the function, and you will see what I am talking about. I'm going to open this with a live server, with a extension called live server. So that will make it easier for me. Okay, it was not open properly. Let me do it again. Close this and maybe selecting this here, open with live server. Yeah, I had to open it, the HTML, sorry. Uh, so it's loading, and you see, you saw the body with the color I mentioned. It's like a neutral color, biscuit, it's called. And we have the canvas, fully black, fully opaque, right? So let's return to our code, and let's unblock some more things. Let's uncomment this, what I commented. And let's see. This is the vertex shader program. You remember I mentioned this GL um, S GLSL, yeah, GL shader language. Well, this is about that. This is what we need to tell the canvas we want to draw a vertex, or in this case, four vertex, a rectangle. Oh, yeah, sorry, I completely forgot that. I always forgot that. Uh, Please don't forget to check in. Here's the link. Thank you so much, UMF01, for sharing it. It's https events.mlh.io slash events slash 11155. You don't have completely to put that. Let me share the small one. Uh, oh, you always forgot this. Sorry, and that's very important. Hmm. Hmm. Oh yeah, it's here. Thank you so much for remembering that. So please go here and check. Here. You can see my hand. Okay, thank you. Yeah, thank you for the big taps. So returning to the code, here we define our square or rectangle or form or vertex. Then we define the fragment shader. So we say like, hey, we want this to be, how to say it, a fragment of the shader coming next. And these two are very important because we need to pass this to a function called initialized shader program, and this shader program is hosted on the program info. So you know, well, if you don't know, this is not that common on JavaScript, right? We are talking here about void. You're Why you have to specify that? This is JavaScript. You're talking about here about attributes, uniforms, the type of function. These kind of things are not JavaScript usual things. So this is what gets complicated because remember we're running another language inside JavaScript, which is this GLSL, GL shader language. But let's take a deeper look to what this init shader is. Well, this init shader takes the GL interface or B source, which is our vertex, and the F source, which is the the fragment. Sorry, and it creates a vertex shader, a fragment shader, and it goes attaching these to the global instance. So we have to take a look to what those attach shaders method is, link program is, and well, you can see you have to specify a lot of things. Let's take a look to the rest of the code. We got our shader. We set that shader to the program information. We set attributes. We set locations. We say we mention not pixel by pixel because that's not practical, but internally that's what's happening. Like we're saying, like you're going to turn off or turn down or be this color or have this position or these kind of things to a map of the canvas to just say draw a scene. And this is static. You cannot imagine how terrible it is when you have motion, when you have not only a two-dimensional thing, but a three-dimensional thing. Um, we create the shader, we load the shader, we set buffers, we set the position of this, we create a buffer of colors, and finally we draw the scene. And with all of this, we get just take a look at this. This square inside the campus, which is black pig, but fully colorized from one corner to another with the RGB code. I remember I have a class. What was it? I think it was LabVIEW. Yeah, LabVIEW. One one of our first assignments, like a homework we had, was doing this in low level programming language. This is very complicated. It took us almost 300 lines of code to get this square. Now imagine building a video game around this. That's lots of work, right? Well, let's put that in practice. Let's see if that seriously is a lot of work. So I'm going to close this, collapse it, clear our port, create a new folder, and let's call it raining rectangles. And inside this, we are going to create a file called index.html. And I have the code of this here. This is one of the examples of the series I mentioned before, the WebGL by example, that can help us see what building a video game fully by delays. So this is a simple game. The object is very simple. We have to click on the rectangles before they fell. So I call 2, 3, 3. Oh, well, it's not that simple. It's hard. 3, 4. You see, no, this is a game. Is there a GitHub repository for this code? For the one I just shared, no. Uh, let me look for it. I think yes, but for this one with the raining rectangles, yeah, for sure. Actually, they mention it around here. In addition, have demonstrates blah blah blah. Okay, yeah, the source code of this example is available on GitHub. Here it is. So let's open this, and probably you can find something similar for the one I just shared. I built that with the documentation, but I don't know if there's a repo containing like the full document. If not, I can make one and share it later. Don't worry. So reading rectangles.html, let's see what happened and what have it inside. We're going to copy and paste this in our own code. So this is an animation and user interface with scissoring. If you want to learn more about what scissoring is, it's as the name says, it's cutting shapes. Um, you call and takes the number of rectangles we call. You missed and increase the number of rectangles we missed. And just in case the browser doesn't support, a message that your browser does support HTML5 canvas. That will be weird, but it can happen. And then let's open this JavaScript. Not that a big file, right? It's just more than 100 lines of code, but we have more in just the previous example, right? So we need to create a file that it's called raining rectangles.jas, and here's the code of it. This is a function. Why it's grabbed in this parentheses. This is a way JavaScript executes itself. If you don't want it, you can delete those wrappers and just auto implicate the function call. Well, in this case, they didn't even add a name, but I will explain that's a very simple JavaScript concept. You saw. I call this main, but all and I execute it just at the start of the file. I can do that in this way, or I can just grab here this, collapse, and do this, and that will work all the same. That's exactly the same. And in this case, as the function it is now invoke somewhere, you don't need to name it. Like that's a trick thing. So you can just run this way and it will work just fine. If you want to do things in a more old-fashioned way, you can always call it main and run main, right? So this is valid, but same as calling it with a name. So just copy the code for the website. Yeah, and let me share this repo with you all here. That's the specific file for the JS we're getting. Remember to have your HTML too. But yeah, let's see what's happening here. First, what's the use strict? Again, this is something about JavaScript that says that you need to use JavaScript in a strict mode. I don't fully understand, to be honest, what use strict is. I see them in a lot of backend code, but don't completely know what it is. But yeah, so the window that add able listener load and set up an animation. We first need to know that the window is not loading, and this is set as a callback function. The function setup animation and defaults. I think it's the parameter passed here of the event, right? So We declare some variables like the timer, the rectangle raining, score, the missed score, and the GL instance. Then we set our animation function that receives an event, and for this case, we set the remote error listener uh, for the event the type, and again set up animation as a couple function. If the GL it is not complete yet, we get the render context. So if it is not valid, this function is returned, and the GL is enabled with the scissor test. Raining rectangles have a new it's a new instance of the rectangle uh, object, and the timer it is just set by the timeout. This is a regular I- sorry, this is a regular API from web, right? So raw animation, it's the other function that it passed as a callback, as callback that executes after 17 seconds, and the document gets the canvas of the HTML. This one here. So you remember we do this previously, but in this case they are not declaring any ID or anything. Just um, well, they are only getting or they only displaying one canvas per HTML, so or per page. So in this case, the query selector just get one canvas element. And for this canvas element, we need to add the event listener. Again, this is great, I know, in a very weird JavaScript, uh, but all JavaScripts are valid. So this will be similar for you to understand this as if we have declared, let's say, canvas that is equal to the document dot query selector called canvas, and then to that canvas with a apply the add event listener, pausing the click function play oh, the click function, the player clicker, and the attribute false, right? So the player clicker is another callback function. And in this case, while this is documenting, we need to transform the position of the click event from window coordinates to relative position inside the canvas. In addition, we need to remember that the vertical position in WebGL increases from bottom to top, unlike the browser window. So remember, imagine this is the window. We were walking with positions over the browser window. We have our zero here, so we're increasing this way and increasing this way. In the WebGL, it does not have the similar the behavior. It is the opposite. It increases from bottom to top and from here to here. The x-axis, you can think of the same, right? So we get those positions from the event passed as the parameter. We get the page x, and um, we perform these operations to get a x and a y. If the click falls inside the rectangle, we count it and we increment. Well, this is just logic on how they perform this, uh, getting the exact position. And we have a rectangle function. This rectangle it's called here for the raining instance. So we keep a reference of the new rectangle object rather than using this keyword because this is functional programming, But remember, you can always do this in object-oriented programming, and that way you can declare a class instead of a function. Um, Remember, all in JavaScript, well, yeah, all except the primitive values are objects. So even the functions are objects. That's kind of tricky too. But yeah, this is the functional approach to solve to sort that. We get rect as this. This is the reference of the instance. In this case, this at its inside the rectangle function refers to it's okay. It refers to the whole environment, the rectangle environment. So we get the three numbers and use this for its new rectangle size position. For each we use a different number because we want the horizontal size, vertical size, and position to be determined independently. Okay, and it is just read nonce can get random vector, and that's all a function. That function lives inside a rectangle. Again, this is the functional programming approach to for what I think uh, 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 an object programming kind of thing ways, right? So a good exercise could be rewrite this code in object programming. We don't have time to do this. We just barely have time to analyze this code to put it up and running. So once we have these positions and the size of the rectangle that are independent for each time we get a new instance of this rectangle, we return it as no. Nothing else happens here. We don't need to return because we're creating a new instance every time. Rectangle, rectangular position, rectangular velocity, and rectangular color. For example, if you remember the example, you saw that rectangles were falling different velocities. In this case, we can change this line to make them go one simple velocity all. Well, we will change it in a second. Get the render in context. This is similar to what the function we had here about drawing the scene. So we need the instance of canvas. You saw in this case they declare this canvas from the query selector. Canvas dot width, client width, canvas dot height, canvas height. The GL context, we need to set this. So where we are running this, it's if the GL isn't declared, it is declared now. And once it's enabled, again, we start running the game by calling the instance of the rectangle that we saw, by getting the click event on the document. By the way, we can delete this now. Display the strong thing for increasing the score and the misses score. And finally, we draw the full animation, right? So I needed to explain this code. I know it's not fully comprehensible. Again, I know it's kind of hard JavaScript, but you will see this hard JavaScript again. It's just for a single game, right? Um, but don't let you uh, disappoint. Don't be disappointed this far. No one said it was easy. I think we have some common here. All right, I'm gonna go to bed. I've been up coding all day. I'm tired. Yeah, I know. You have to rest, and that's really cool. Have a good night, and well, you can always see recording later. Have a good lettuce night. That's really cool. Good night, Chad, and some dinosaurs. That's cool. So we continue, and when you see this stream, the recording, you will get excited again. So let me run again the index.html file as a live server. Okay, but this is ugly, right? Because we barely see where the canvas is and stuff. So we're going to modify that. Close the port because, well, it's hard to render. Let's add a style to this display flex flex no justify content center. Oh no, I do a grab. Well, yeah, it can work. No, yeah, I'll do a grabber for this, and this will be background color. Did you like the color I used before this biscuit, or we can go for a light blue? Oh, light salmon or light green. I think this will be good. Then I will do a wrapper for this. This will be uh, old fashioned deep. Then we add this here. Canva. Canva. Okay, let's see how it's going. Can we use in simple web pages like on looking solvers? Yeah, of course you can. I mean, I just do this like for, well, it's an extension of VS Code that you can install. And the good thing here is I can just change, for example, for this P or how this is style, text align center, and I can see the changes reflected here. So another thing I want to do is open this one. I want to put it at the right. Hmm. Okay. Another thing I need to add here is flex direction column for the canvas. Maybe background white, border 2px solid. Uh, what else? Uh, Green. No, maybe black. Okay, so let's do it that way. Mm, flex direction column, canvas tile, background color, assure for their 3px solid black for their radius 1.5px. This is for VS Code. Simply you just need to install live server extension, and on HTML click on live server icon button. This is for VS Code. Yeah, but as you mentioned, you can always just go to your where you have your files on your computer, Finder for Mac, File Explorer or something like that on Windows. Double click on the HTML and the whole thing will run, but you won't see the changes reflected until you open it or reload the page. The thing with live server extension is that you can see live changes fully running and stuff. So that's all. Hmm. And I can set some last things. That is um, with hey. Let's see how this acts. Only the thing I'm missing is a line. Item center. And the text I wanted in color font weight a little bold. Okay, now this is running and I am playing. I catch one. No, I missed that. I catch two. You see how these different rectangles come in here. Now we need to modify this in order to see how the things we done in the file affect the game. Let's do that. First, let's start by changing the the velocity of these uh, rectangles. This is math random from 1 to 5, but in this case, we were going to set it to 3. Just 3. Simple as that. Let's see if this reload and how it behaves. You will see this velocity of 3, it's kind of not that slow, but either that simple, right? More if the sizes of the rectangles are not that big. For example, this one is small, and I couldn't do it. I do it. Okay, here, you know, and you can spend a good time playing this, but you may thinking, Alberto, why you changed the velocity? Okay, you see, it was kind of hard, but not that hard. You can think it of as a medium level. But now I will set it to 1 and let it reload. This is low, so clicking on this is easy. Okay, again. So you can think of this as a easy level. So imagine that you put an interface before starting um, this is this game. You selected and you create an interface before this, and you set some variables as difficulty, and you add a timer here. So let's think of how many rectangles you can call against the clock in less than 5 minutes or in less than 1 minute. And you can play it with these variables. So let's return the velocity how it was. And let's change now some sizes. Same, it's your game. So you can think of whatever rules you want to change in order to play this. If you want to add a bigger rectangle, you can do it. I just change it. I just do it 50 by 50. So all rectangles are going to be squares. And here, oh, I click it. I miss it. Sorry, I miss it. This one I click it. This one I miss. This one I click. Because velocity here, it's a variable and it's random and I cannot control it because I change it. So what I have left is to play against the same size of rectangle in a different velocities. Now, imagine you set limits again and you combine this. So, difficulty easy gives you big rectangles going slow down, right? Now, medium, it's kind of medium-sized rectangles like this. This is not that big, but also not that small. And they go kind of fast, but kind of slow. This one just the orange one was fast. This green one, it's the medium point I'm talking about. Same as this blue one. This is slow. This will be an easy one. But yeah, you can change that. So let's return this to how it was. Huh. What else we can change? Well, we could add using the audio API some music. So imagine adding music to this game. So you will have a very, very complete game with the interface. You can go deeper and deeper and deeper because the hard thing was to codify this. Imagine doing these things like the filling rectangles with CSS. It's I cannot think of a way of doing it if I'm honest. Um, so we quickly pass for from doing a very simple thing that it's drawing a rectangle, a square in CSS that take us a lot of time and a lot of code in WebGL. So if you're just drawing rectangles, just go CSS. But if you now need to move these rectangles in a canvas and take the score of clicking on them and applying a game bracket, well, you see now the advantages, right? Because we have that question, like why we care about these performance, why we care about building these on vanilla. Well, this is why, because now we can get lots of fun, and that's here's an advice. You can find this animation and user interaction uh, code in the WebGL examples, but also you can find another very useful piece of code that it's a boilerplate. Here, this example describes pieces of code that you will be hidden from now on as we define JavaScript utility function to make WebGL initialization. So you can take this boilerplate code again. If it's in the same repo I just shared here, it's the boilerplate one, and you can see the CSS, the HTML, and the JS files here. And you could take this repo and start experimenting with all the examples they have, like the color masking, like the vertex attributes, like the scissors animation. Like what else? The if you want to learn more about GL, what it was SL shader language, yeah, they have an example here on simple color animation. Well, the simple color animation takes it makes use of GLSL, but that, that's it. So we still have time for another example that I wanted to share. A more interesting one. What I think that it's the 2D breakout game using pure JavaScript. So if any question this far, I will happily answer them. Just put it on the comments. What do you think? Do you like this mini game we built? Okay, I am hoping you're liking this. Let's continue to our next example. That it's the breakout. game, and we're going to again get the code from this and just start exploring them. Let me see. Let me look for the finishing up. Okay, we are going to copy, but I think in raw it's simpler. And we are going to create first a new folder called breakout, then a new file called index.html. And I have to be honest, I don't like scripts this way. So let's cut this one, add the div or classic div. Here, here, script source breakout JS, add a new file called breakout.js, and paste what we extract. Then put here, copy, delete it, and see again what's happening here. Well, this canvas is set from the get element by ID. Um, Again, we set this ID. This is a cleaner example, more than the raining rectangles. Let's close them. Um, we got the context. In this case, they are calling them CTX. Whatever works for you, it's fine. In the previous examples we saw, this it was called GL, right? But in here, CTX, it's good. Then we declare about radius, the how to say it, the width and the height of the canvas we have. This will be the working area we have, an X and D. Then we have to have a differential of the working area, that it's the X and the Y. Then the paddle height and the paddle width. Uh, we can play with this, the whatever size we want. Um, then the paddle X, it's the canvas width. I mean, this position, it's the canvas width minus the paddle width, right? So we have sellers for if it is left pressed, right pressed, the brick row count, the brick column count, the brick width, the brick height, the brick padding, and the brick offsets on top, on left, the score we have, and the lives we have, right? So we clear a brick, right? And for the brick column, we are going to create new bricks and set these positions and statuses. This is an object defining the positions and if it is displayed or not, status 0 or 1. And then we add event listeners for the key up, key down, and the movement of the mouse. So we set functions for every case in which we press the right arrow, the left arrow, or if we move this mouse, right? So we have another function that's a collision detector. So if the ball collides a brick, the status changes. Then we have a function for drawing the ball, a function for drawing the palette, going again. In this case, it's the context, but it's GL in instance, and then we began the path function. We draw the bricks, same as we draw the palette and the bolt, and same as that, we need to draw the score. We can do this on WebGL as the function of the field text, but also we can add, same as the previous example, just a P in the HTML, and with JavaScript, give it give like the like increase the account of changing the pure HTML. But in this case, this game it's focusing more on pure canvas, a pure GL. So this is very good because you can take a look of this example as if it was a desktop game. Like in the desktop game, you cannot use tricks to base code or things like that. For example, the ones who remember the Tetris mini game tournament we have earlier today, uh, imagine seeing the score with the HTML. Like, it's not that exciting, and it makes you feel like you're not in the game entirely, right? So finally, we have the draw function that changes over the time how this game it's rendered, and the draw it's set it's run continuously. So we need to go to the HTML again. We need to open this on live server, and let's see what we have. Hmm. Look at this. We have some errors. Let's see if we can get the errors again. Type error canvas is new. It's new. Uh, breakout yes. Look down install. Hmm. Canvas. Bar document get element by ID canvas. Hmm. Let's do that thing that we talk about. And here we have it. Let me explain what happened there. If you remember, here on the original HTML file, we had the canvas, the body, and everything, and just at the end of the body creation, we had the script one. That works fine when working on the same um, file, but in this case, we're getting the script for another file, for an external file. Uh, in this case, we have to set priorities. Remember, at some point, you probably have your scripts. You probably have your styles and your HTML. In this case, we call it your structure. But if your script tries to call your HTML before it is rendered on the DOM, then you have a problem, and that's what the error said. Uh, Canvas is undefined because it was not ready. In this case, I just put it inside a function to give some time to the DOM to be ready, and then that was it. That it was just a little trick. Okay, but the game is over now because I have no lives. So let's start again. I'm pressing the arrows to move, and now I'm moving it with the mouse. I think with the mouse it's smoother. Yeah, how do you like it? I feel like when I come here, I could. I don't know. I don't like the sensation of the working area. Remember, we mentioned that. Remember, we declare it. I think we can change some parameters here on X to do it lighter. Let's do this 40. And I have another. Well, I run out of lives. Okay, very good. And you see, when I run out of lives, get this avid listener that tells me, sorry, the alert. This is ugly, like a web alert that just gives you a game over. I don't know. I kind of don't like it. That's a good point of improvement, actually. So this is the explanation of the game. Again, you can take this code, which is here. Let me share it. And make lots of improvements around this. And we're almost done with our today's session. We checked the rectangle example, we checked the raining rectangles game, and these breakout game too. So we build now not only one but two incredible games using just JavaScript. And purely on the web, and that's it's amazing. One thing I want to show you to wrap up this session, it's this game dedicated section. You can find more about in which cases you want to use more HTML tags, in which cases you want to focus fully on the canvas, in which cases you want to add manual CSS, in which cases you want to use GL. SL, which is the shader language for WebGL. Um, Remember, this is really low code. So in some cases, you'll be writing C inside JavaScript, which is uh, kind of weird if you want to say it somehow, some way. But also, I want to show you this part here that tells you the list of no, where is it? Well, now I'm done finding it. Okay, I think here it is. Actually, no. No, this is not the one. Well, this is very interesting. Game programming patterns. Ah, yeah. HTML5 game engines. If you like video games, you're probably familiar with Unity or Unreal, which are game engines. Well, these game engines help you to tell it in a way to perform complex operations that will be really hard to program in our own way, right? So, for example, imagine now we show how to represent the following of a rectangle, but try to replicate the falling of a three-dimensional bullet in your what's the name, Call of Duty web development version, right? Well, the good news here is that most of web engines perform physics operations because they have them built in. So you probably have to fine tune a little bit, but the falling of an object, jumping, moving in a two or three dimensional space, um, well, you are covered in that way. So play canvas. It's I didn't find the specific section for this. It's somewhere like somewhere around this web development thing has information about play canvas. I don't want to spoil you again. Play Canvas is the game engine we are going to use in our final session of this series. Remember, our next session tomorrow, we are going to talk about frameworks, which is different from a game engine, but frameworks would allow us to quick develop 2D video game as we done in this session. But more complex, obviously more robust, and in a better way. Let's say it, to mention. And Play Canvas, it's the game engine that will allow us to work on web. And just seeing this demo, you can easily relate it to Unity, for example. I think it's the most popular one. So if you have worked with Unity game engine, it's easy peasy. So thanks a lot for joining me. Uh, that will be the last of this session. It's been uh, wow, intense day. A lot of it's like 3 as. That's well 3 as. For what I understand, it's more like what we are going to explore tomorrow, which is the framework, right? Let me see. I don't want to lie to you, but because I've seen 3 as, but I'm not that familiar. 3 as. Yeah, no, completely. 3 as it's not even a framework; it's a library. But yeah, it's 3 as makes you easy to work with three-dimensional graphics in in JavaScript. And again, this is where all things start to make sense because underneath 3GS Phaser, which is another framework, it's really cool. You have to check it. Well, library, um, Play Canvas. What other we have? There are very few of them. Like you can check them, but all of them underneath uses WebGL. So at some point you needed to learn WebGL, right? So this was your introduction. Now that you know how WebGL works and what does WebGL do, we can start using more complicated things as 3JS, as Phaser, as Play Canvas, and all these great tools to now quickly develop games on JavaScript. But yeah, amazing question. Thank you. So again, thanks for joining me. Yeah, can't wait too. See you tomorrow. Thanks for joining me, and I will see you on 2 more days here on Global Hack Week. Please stay tuned for what's coming up, and well, hope to see you tomorrow. Bye. Have a good night for those who are, and it's ending, and have a great morning. Uh, yeah, that's a good question. Have a good night or a great morning. Have a great morning for those one who are waking up, or for the person who was 11 a.m. in the morning. So that's amazing. Bye bye.